compensate for the drag. The second part is we need to have some mechanisms to generate lift, because it's not sufficient it goes straight. It's not like a car now on the road. It needs to sustain, it's airborne, so it means it needs to sustain for the weight. So if you look from the basic diagram or how the equilibrium is for an aircraft, there is this thrust which I will denote it as F, which is the force. So thrust force which compensates for the drag, and the lift force that compensates for the weight. So this is how the force systems, the primary forces act on the aircraft, and it is in equilibrium for a steady flight. So thrust and the lift, there are two forces that you need so that you can have a steady flight, steady level flight. The third is you need something to control the system. You have an aircraft, it's not sufficient it always goes in a straight line, or even if it wants to go in a straight line, there could be wind disturbance or anything that would somehow need something to control the aircraft or keep it in this trajectory in which we want, not the way some way it needs to fly, it can fly. So this control is obtained by using some control surfaces on the aircraft. For a fixed wing, if you look at the wing, this is the wing, you would have seen if you have flown in some aircraft, you could have seen there are something called some flap kind of thing here that goes, that deflects. These are some of the things are the edges, and the ones at the edges are called the ailerons. And there is a reason why they are the edges, or I mean towards the ends, because they create what is called moment. Most of you should be familiar. If you have a force and there is a, just think of you're opening a door. You're applying at the force at the end of the door. At the hinge of the, there is a hinge and there is a door. You're applying a force at the door. You are rotating about this hinge, correct? So this is caused by the moment. So just like you have translation force, translation means going in a straight line, and straight line or in a 2D plane, let's say it's moving, it's just moving in one some direction. You have force that brings in acceleration and hence the Newton's law. Equivalently, you will have for rotation a similar scenario. I won't go into moment of inertia, etc., but you understand there is something similar in rotation also. The concepts are same. It's nothing different. Same thing what you call in force is exactly same. When you apply it to rotation, it comes out to be angular rotation, angular acceleration, torque. The torque or the moment becomes equivalent to the force, and so on. As far our current discussion is concerned, all you need to understand is when you deflect the ailerons, what is called as ailerons, you are going to generate forces in opposite direction. One side there will be lift, other side will be, I mean, both sides will be lift, but one side will have a higher lift compared to the other side, which will create a turning moment. Just think that this way, if you're in a seesaw, you apply more force on one side and less force on the other side, you will the seesaw will rotate. In the same way, you apply one side, you apply more force, other side you apply lesser force. You will experience a rotation. Which means the forces are not, it's if you consider at the same point, or even if you consider the same force, same magnitude, but they are in opposite directions, like what I sketched here, even then it is about to rotate. Same way, if you are pulling it on one side and if you're pushing it on the other side, the seesaw will rotate in the same, exactly same things. So there is some moment that is being created. I will use the word moment. You understand that it is, I'm talking about something that has a tendency to rotate things. So this moment is going to rotate the aircraft. So this is how the aircraft roll. It's called roll, like bank. It is going to turn. You will see the aircraft is going to turn. You will, when an aircraft is going to turn, you will see the aircraft is rolling. That is, it is going to tilt like this. So that is roll. So, but this is not alone sufficient. We need other things also in the aircraft. So there are, if you look at the aircraft, you may see at the end there is something like this. And at the edge of that also you'll see something that can be reflected similar to these ailerons. These are called elevators. What they do is they provide a moment about in this direction. So it will try to rotate the aircraft like it's called the pitch, nose up and down. So that is how it rotates. So this is called, this control surface is called the elevator. And there is, so there are, you should understand this way. If an object is the rigid body is there, think about something. Let's say there is a mouse. This mouse, yeah, if there is an object like this in space, it can rotate in different directions. So there are three axes, like you can say one axis is this way, one axis this way, one axis this way. So we can rotate in any of these directions. So if you want to have perfect control, you need to devise some strategy where it can control the motion of this object in space in any direction it wants. So you have three rotations, and that's how in aircraft also we have three rotations. We have pitch, roll pitch, and the third one is called the yaw. And yaw is done by, you have With this aircraft, there is it's called the vertical tail. On the vertical tail, the edge, you will see something called the rudder. So that again reflects the principle of operation for the ailerons, elevators, rudder, they are all the same. There is no fundamental difference between their operating principle. It's just that how they are placed on an aircraft and how the aircraft will respond to its deflection. That's the only difference. If you apply this rudder, the aircraft will yaw. That is, it can turn in this direction. So the aircraft itself will turn. So when you're when you need to rotate the aircraft. So for example, you are coming near to a runway and you are to align to a runway. You need to rotate the aircraft. So you apply rudder and rotate and then land. So there can be rudder operate at some point, elevator, aileron. Sometimes they are operated in simultaneously also for different reasons. So ailerons will allow the aircraft to roll, elevators will allow it to pitch, and rudder will allow it to yaw. These are three different motions, and these are three control surfaces acting on the aircraft, available on the aircraft, fundamental control surfaces. So three things are over: thrust, then the lift, and the control. What we saw in this process is that for each of these things, for a fixed wing aircraft, that is normal aircraft which is flying, has independent systems or components. For thrust, we have a propeller or an engine. For the lift, we have the wings primarily to generate the lift force. And for the control, we have the aileron, elevator, rudder, and so on. So we see that there is a nice distribution of responsibilities for different components in the aircraft to handle these three important tasks. But when it comes to rotorcraft or helicopters, the problem is that all these things has to be done by one important component, which is the rotor of the helicopter. And it's a nice way it does too. So you have a rotor. Let's look from the top. You have the blade. I'm just drawing the edge of the blade as a circle. There is a blade that rotates, and as it rotates, we know that since there is a rotation, there is a motion of as on the blade you will see a motion on the other direction. So it will generate lift, just like what you see in a fixed wing. Now, lift generation is okay. That means you know that if there is a wing which can be moved forward, it can generate a lift because of its velocity. Then, same way, if you have a blade or a aerodynamic surface, in this case a wing, and you rotate it, it's similar to this velocity, just that the velocity at each point will change with respect to the radius. I am not sure 10th standard students would have seen. Others in 11th and 12th would have seen that you have omega into r. Omega is the angular velocity. R is the distance from the center of rotation. So this will be the velocity at each point. Now, since the wing can create a lift because of its motion with a velocity v, a blade also, when it rotates at angular velocity omega, it can create a lift. So lift can be generated by a rotor. Now, second question is, lift is fine. What to do with thrust? So we have a rotor. It can generate a lift. So it can do something called hover. That means it can sustain its weight. There is a weight acting opposite to it, and there is a force that is generated in the opposite direction, which compensates for the weight. So weight is equal to the thrust, and this thing can hover. So lift. So whatever we called as thrust, let's in the previous term, in the rotor terminology, it's called as thrust. But you can more or less understand that this is the lift generated by the rotating wing, and that is going to compensate for the weight, just like in aircraft. Now think that you want to go in the forward direction. What is the fundamental thing you need to go forward direction? If there was no air resistance, it could have, there is only a need for, you can just move. You can just have to tap it on one side. It is going to continue Newton's first law. It is going to continue its motion forever if there is no resistance in the opposite direction. But that's not the scenario here. You know that there is a drag. Whenever an aircraft moves or the helicopter moves in the forward direction, it is going to experience a drag, which means you need some component of force that can compensate for this drag. Now, how do you generate this component is a question. It can generate the lift. So idea is you tilt the rotor slightly or minus. There's a one component of the thrust is in this direction, or the lift is generated in this direction. One component of this will compensate for the weight. Other component will provide the force opposite to the drag. So the thrust which we saw in the fixed wing is also given by the main rotor. So thrust and the lift, both responsibilities on the main rotor. Now it doesn't stop there. Even the control is also done by the main rotor. That is a little more complicated, but I'll just try to see if I can quickly tell you. The idea is that if you have a blade, somehow you can change the pitch of the blade. That is, the blade can rotate about its axis. So this is the blade, this is the axis, it can rotate. So this is the blade is rotating. I don't know whether you're able to see it. It can rotate in this direction. So this is the, let's say this the blade is rotating. It can rotate it along its axis also. That is, it is attached in this direction. It is attached in this direction. Let's say it can rotate in this direction. So this is adjusting the pitch. So when you adjust the pitch, there can be more lift or lesser lift. So as it rotates, if you can adjust this pitch, you can see what should be the moment that can be generated at the hub. Or hub means wherever the blade is attached to the one something called the shaft. Let's say the shaft is there. The some cylindrical rod, if you want to keep it simple, the blade is attached to it. It can generate some moment about this hub and hence about the helicopter, and it will about helicopter CG, center of gravity, and it will rotate. So the control of the helicopter also is done by the main rotor through the change of the pitch angle of the blade. By the pitch angle of the blade, we mean at what angle it is oriented with respect to the plane of its rotation. So if this is the plane which you see on the paper is where it is rotating, then you can move the blade. Just if you place a pen on the top, for example, then you just rotate it upward. Then it is having a pitch angle. It's called the pitch angle. I know it may be slightly above whatever you can understand, but just see this is see whether you get the overall picture. That's all is important. So fundamental messages: you have thrust, lift, and the control. For the rotorcraft, all three of them are primarily done by the main rotor. However, there are other things also that is required. For example, if you have, let me write in the next page. If you have tail rotor, there is something called the tail rotor. So you have, this is helicopter, this is the main rotor here, something called the tail rotor at the rear end. Why this tail rotor is required is when you spin, as from Newton's law, you know that third law, there is equal and opposite reaction. So similar to force, the same thing applies to torque. Torque means something when you try to turn, you apply what is called the torque or moment. When you apply, so the main rotor or the rotor to spin, that is, this is the main called, this is the tail rotor. For this main rotor to spin, you need to apply something called the torque. Okay, just like you have any motor, you have a motor and you are attaching something on it to spin your mixer grinder, whatever it is. You are applying a torque at the bottom, and it spins the whatever is attached to it. So here the main rotor, there is an engine that is attached to the main rotor through some gear mechanism, and that will drive the rotor. Now, when it is given a torque in that direction, the opposite reaction will be seen by the fuselage. That is, the fuselage, if you don't have a tail rotor, the fuselage will spin in the opposite direction. So this is what is compensated by providing a tail rotor, because if you look from the top, this is a tail rotor. It will apply a force in this one direction, and if the main rotor is rotating, so this will rotate in this direction. It will try to keep moment in this direction. So the fuselage, if the rotor is rotating in this direction, the fuselage will try to rotate in this direction, and it will again, the tail rotor will compensate for it. Now, you just need to understand that tail rotor is just going to provide a force, so that the helicopter, it doesn't rotate on its own. So this, just to avoid that, we have this. As in other options you have for the helicopter, you can have something called coaxial rotor. There are not many big helicopters that are coaxial. Most of them are in this configuration which we say seen here. There are some like two rotors in this direction, like big helicopter like Chinook and all. They call it tandem rotors. Otherwise, most of them are in the single, the conventional form. The other one is the coaxial. The Ingenuity helicopter which flew in Mars was of this coaxial category. You have two rotors, and if one of these spin the opposite, two both will spin in opposite direction. So this cancellation of torque happens. So it's like you are pushing from both sides and on opposite sides on an object. The object will not move. The same way, you're trying to rotate an object. So you have pen. Let's say I'm trying to rotate both from top and the bottom in opposite direction. The pen won't rotate. But if I don't apply any force in the direction, if I turn from the top, it will start rotating. The same way, if you have two rotors and both of them are trying to apply spinning in opposite directions, the helicopter will not rotate. And if you want to rotate, you can change the speed or other controls and then make it rotate. This is a fundamental principle in which the helicopters operate. I think that should be enough for the overview. I just want to convey the fundamental principles involved in this. I'm open to questions. You can whatever was discussed in the lecture which you might have seen, you can ask. Please go ahead. Whoever has any questions. Not only on what I discussed today, whatever you might have watched in the previous lecture, previous week. So, no questions from anyone? How many of you followed the discussion what we had now? I just want to know whether, can you raise your hand? Okay, Chandrasekhar. Okay, any questions? Okay. Darshan, you have anything to discuss with them?
Nothing much. This I think it's fine enough. What you have.
Okay.
I don't know, the number of people is also less.
Yeah, students are also less today. Not sure.
Maybe for 5 minutes we can see if they have any doubts.
Yeah, if not, we'll just wait for 5 minutes. If you don't have a question, we'll end the session. Or if you want me to discuss any other topic, please let me know. That also we can do. Next week we will overview the quadrature.
Quadratic. I think that is enough. Take home assignment is given.
That's already given. So your take-home assignment should be already available to you. Do you want to explain something on that assignment?
Nothing.
Maybe you can explain what to be done so that will help them.
So
You
basically,
can come. It's okay. I'll just hand over to Rakshan so that he can describe what to be done for the take-home assignment.
so the take home assignment is pretty much simple. So what you have to do is like run the Python code. So first you have a Python code, and I have given a separate file because last time we had some issues. Right now we have a separate Python file. You just run the code and you find like there will be 7 to 8 questions available to you. So it will be mostly numerical and MCQs, and it will be circulated on the form. So you run the Python code. You get like based on the questions, you change the parameters like mass and acceleration due to gravity and all this stuff, and you will get the results basically. So for numerical based questions, I have given the instruction whether you have to mostly, if the answer is numerical, please make sure that you round up to two decimal places. So that's the one thing I wanted to say. Like everything else is simpler. So you just go through the code and understand and answer the questions. So that's the part.
Just ask somebody has seen that they got the questions.
Did you get the take home assignments? Did somebody get the take home assignments? Are you able to see that on the spaces like the NPTEL website?
And someone confirm if they have seen the questions there in your portal, web portal.
You can just raise your hand, it's fine.
Yes, Anya? We can't hear.
The same website where you are going through all the contents and assignments. Same website.
Sorry, your voice broke. Can you please repeat, sir?
Am I audible right now?
Yeah, yes, sir.
So basically, the take-home assignment will be available on week 7.
Okay.
So can you confirm once whether it is there or not? Hello.
Yes, sir. Checking seconds.
There is only practice assignment and graded assignment.
Yes, sir.
Okay, I think they will update it today. I'll just talk with them. So this is the point. Like, so basically, you have to run the Python code and get the results. So that is the it's just a simple assignment, but you have to understand what you're doing. That's it. Nothing much to be done.
We have kept the assignment very simple because many of the students are not familiar with computer programs, what to do, etc. That's why we kept it this way. Uh, because people who are students who are familiar with programming, this may appear to be a very trivial task. But the reason we couldn't give that because last time we found that even such simple tasks, some of the students found it extremely hard because they are not at all used to this programming aspect. So whoever is familiar, it may appear to be a very trivial task, but that's how we have designed this and so that most students can answer it. So please go through it. If you have any clarifications needed, please contact us. The task itself is reasonably simple, and please download the Python code as given there rather than in opening, copy pasting, etc. Just download it and then start using it. You may have to use some editor or some environment to run these Pythons. You may have to install something for running the Python, but that's fairly easy. It should be available on internet. So please give it a try. The technical part of the assignment is quite easy. There is nothing much to do.
So do you have any doubts?
Nikhil, you have any questions?
Yes, sir.
No, sir.
Uh, this is not particularly related to the course or the assignments or anything. But
Mhm.
like, I have a general question in the aerospace industry. Like, how is life in the industry right now, and like, how is it been developing, and like, what are the career opportunities we have right now in the aerospace industry, and like the different things.
I have been here for more than 4 years. Even I don't have an idea on that.
Okay.
Fast solving thing. We wrote.
Yeah, yeah, it's like it changes very often. Like if you see the trend for every 5 years, the technology changes, but mostly like it will be updates only. It won't be a major breakthrough innovation only.
So you should views from in my purse. These views differ to whom you are speaking to. In my view, it appears that the current trend seem to be morely towards the defense sectors. You have a lot of talking about unmanned aerial vehicles and different such
Okay.
systems than talking about designing a full aircraft. So, for example, if you look at in the Indian context, you don't have passenger aircraft built in India as such. And the only big industry that works on aircraft systems or helicopters is HAL. So they do primarily for defense sector. So in future, but we do see that there are companies that are trying to come building passenger aircraft in the country. So such things can come up. So it depends upon depending upon those how those developments happen. Uh, the career opportunities also will change. So what I'm trying to convey is what you call as career opportunities inside the country or in any country for that matter, is strongly linked to the policies and how the overall ecosystem develops. So it's not a very easy question to answer, but nevertheless, I'm pretty sure that most aerospace engineers who graduate can find some core technical jobs if if they do strengthen the skills in the sector because the sector as such is booming. If you look around, especially the UAV sector, there's a lot of companies coming up, and many of the one of the key things right now with the government's policy also is make in India. So which means even a sophisticated aircraft systems also likely to be built in future in the country. So you can expect probably when you guys finish your degrees, you should expect more opportunities than what would have seen 5 years, 10 years back.
So as such, right now, defense industry is like booming so much. What like once like this air ambulances, air taxis used to be a fantasy story, but right now it's becoming a reality. One of the company in IITM is currently working on this air ambulances. They are going to like make 100 air ambulances by the end of 2027. So like that, and right now privatization of defense sector is also happening right now. So you don't have to especially work with someone. You can make your own uh, product and work on it, and then maybe showcase and sell it as a product, or you can make your own company. So at the end, it depends on how skilled you are in the sector. And right now, since like as you can see, a lot of war and like everything around the world, lot of war is happening, and right now the warfare is in the air, like airspace. So right now, this sector is going to boom like so much in the next 10 years. Like the air traffic is going to be 5 to 6 times higher than what it is right now. So the sector is never going to die down right now. Maybe in the next 20 to 30 years, it's not going to be getting down.
Okay. Like one other small note, like can you give a small gist on like the major subsectors in the aerospace? Like you know how we have fluid dynamics, like the major
Oh,
subsectors.
major fields.
It's just
Yeah,
simple.
fields. Yeah, fields.
There
Sorry.
are three fields: structures, aerodynamics, and propulsion.
Okay.
Those structures is where you study how to. So structures, let's say you take a plane. Structures is where you study how to make the plane as strong as possible by using very less amount of material. So at the end, it comes to manufacturing cost and all, and what material to use, which is cheaper, but which, like, you have to consider all the factors you design. While it comes to aerodynamics, you design systems like basically you want the flight to fly as long as possible and however you want it to be possible. So in aero, let's say you want the plane to do a 180-degree flip and all, how you design it comes to aerodynamics. While propulsion is where you choose the suitable system so that it can provide enough thrust or lift such that the aerodynamics part is taken care of. Basically, if you want to the plane to fly at if you want the plane to fly at Mach 2 or something, you have to choose the particular propulsion system. And propulsion, you choose which like system is much more effective, and all this stuff comes in the propulsion part. So these are the three major parts in aerospace sector.
Just to elaborate with what Prakshan said, if you're looking from the context of the subjects you might have heard, when we say structures, you will look at the static structures, static analysis of structures. You may need to understand this, something called the stress, the strain, and such quantities. There are multiple if you're looking at the curriculum of an aerospace engineering course, you will have multiple courses that are aligned with these aspects. Then when you come to, since you said fluid mechanics, they all come in a broad division of aerodynamics and flight dynamics, where fluid mechanics typically it's air, liquid. So you study some of the basic components. So in then you study about aerodynamics, low speed and high speed. So then you go to the flight dynamics, how the aircraft flies. Then you may also want to study about how the spacecraft flies. So all those things come in aerodynamics and flight dynamics. And then when you look to propulsion, you have how the engines, what are the thermodynamics part, then how thermodynamics something which you may be studying in a plus two, so which you may be using those concepts also there. And you will have engines, which engine to be used, or is it like an turbojet engine, turboprop engine, all those different designs and all you will be learning in propulsion part. If you're trying to link it to what, may I know, Nikhil, which class you are in? Are you in 11th, 12th or something, or 10th?
10th right now.
10th. So you may not have seen many of these subjects even in a crude form. For example, if you're in 11th and 12th, you will be introduced to mostly dynamics. You have
Yeah.
you have some understanding of fluid mechanics. So all this the foundation for what you may learn in not only in aerospace, other engineering courses, mechanical also, other electronics such courses also, but particularly from the point of aerospace engineering, say dynamics as well as mechanical engineering, we more looking at thermodynamics, fluid mechanics, which you will learn mostly statics probably in your and little bit of dynamics part in the 11th standard, and you may also study about bit of thermodynamics too. So these things are just, I think, if you look from the overall context, maybe just a flavor you may get in your 11th or 12th, of which you need to learn much more during your engineering curriculum, if at all you opt to study that. So you can, if you are somebody who is interested in dynamics, fluid mechanics, thermodynamics, etc., any of these the topics which this section mentioned, aerodynamics, flight mechanics, so propulsion and structures, they all will somewhere or the other connected. So you can strengthen those in your when you're taking an aerospace engineering career. I hope we answered your question.
Yeah, thank you, sir. Thank you.
Any other doubts?
Sir, I'm Chandrasekhar.
Yeah, Chandrasekhar, please go ahead.
Sir, my doubt is apart from the syllabus, sir, general doubt, sir.
Uh,
Sir, what can I do for my if I done any personal hypothesis theory means? How can I propose it to publicly, sir?
what is it? I couldn't get it.
If you write some theory, like thesis or something.
Okay, I'll tell.
Yes, sir.
Basically,
Like that.
you communicate with the scientific community if you make some discovery. Correct.
Yes, sir. What the first step I want to do,
Okay.
sir?
Typically, in all scientific discoveries, at least in the last 1 century, how it is released to the full community is that there are different, like you have magazines, no, like you have uh, Tintin, Champak, etc. You have several magazines for kids. In the same way, uh, for I'm just making it in a crude approximation, but in the scientific community, there are publications called journals. So one approach is that when you find something interesting on your own exploration and which has not been discovered by others in the past, maybe let's say if you're looking for the mathematics, you found something new, some new identity, some new formula, something like that, which is not very trivial. That is something somebody cannot figure it out in a half an hour, or it's not a standard problem which may appear. I'm not talking about the trivial thing. It involves much more deeper thought, and you have people many people have not come across those things, and you feel that that is strong enough to be informed to others so that they also are aware of it. And in such context, you write in a neat form that okay, this is what I am trying to do. So typically you will have a concise summary, then you expand on it. So tell them what is the overall context in which. So you have to refer to what has been done before in the same theory. Suppose you are devising a new mechanism, you may have to explore what has been designed similarly and what is the new thing which you are proposing and what is the advantage of it. And if you're from the theoretical perspective, there is say these are the limitations. For example, you look at gravitation. You may have 1/r² law. It says Newton had published it, and apparently, suppose you are the Einstein who was there, then he understands that this is not sufficient. So he finds that r² cannot be simply brought in. You come up with some new theory, let's say general relativity theory, and then
Yes,
that is
sir.
communicated to the scientific world using these scientific journals. So these are the journals you send, and it doesn't stop there. You send these journals. There are others who are of similar caliber or who are in the similar field. They send this article, what is called article, which you write, and this being reviewed by multiple people to see whether it is correct and whether it is sensible or is it something that has been done in the past by somebody else. And if it doesn't, and they see a merit in letting this theory be known to the wider community, they publish in this the journal. Why I brought the example of magazines which the kids read is that these journals are also published periodically. Like sometimes maybe quarterly, some maybe yearly, some are monthly. So each of these they will have selected papers from this kind of review system, and then they publish in that. Another path would be there are other avenues also. Like when you finish, you may not be sure whether it need to be right straight away put in a center or communicated to a journal publication, but rather there is something called conferences that are held in different places in each field. For example, aerospace, there are multiple fields. Nikhil was asking, which is different fields like structures, propulsion, aerodynamics. Even here, there are subdivisions, and each of them may have specific conference where only experts in that field come for discussions. So there you present a paper, you have thoughts. There are people sitting, probably 50, 60 people in your room, and they're presenting it, and they analyze your whatever you say. Since they are in the same field, they will absorb whatever you're saying in a quick time. They will have their questions. You may have to defend what you are doing, and when you think it is good, it can be even put in the journal later. So the idea is you either do it through straight away as a journal and through the written medium, or you may be communicating in an oral medium through a presentation or something to a group of people. So there are different such avenues there. But fundamentally, you cannot simply write like a story. You come up and write something and then it is published in a book. If it just it's a matter of imagination.
Yes, yes,
It has to be
yes.
written by a set of people and a system that ensures that it meets the quality level and there is no some incorrect things in what you are trying to propose, because you should not mislead people who are reading your paper. That is how typically it
Yes,
is.
sir.
But if you look from
Yes,
a
sir.
slightly deviated way, if you're more focused on inventing new things, then you go for what they call patents. You once you finish a design, you check whether similar things have been done by somebody else. If no, then you apply for patent. It is a bit expensive that way, but the idea of patents is once you secure a patent, then you have the right to sell the product, and nobody can
For
copy.
that,
I mean, we should be familiar with that concept. It's not only scientific field; everywhere you can see talk about it. So these are the probably ways you could communicate your findings or discoveries to your scientific.
ideas. Yes, sir. Understood, sir.
Anything else?
Thank you so much, sir.
Okay.
Thank you so much, sir.
Anybody else?
Sir, another doubt, sir.
Yes.
Sir, I can't understand that how the like example the hummingbird stationary flying, sir.
Ah,
At
so that
in a
is an
bit of
interesting.
error.
That is an interesting question. So hummingbird is more something like an exception, but they are all see helicopter can fly or hover because it has a rotating wing, and rotating wings can produce sufficiently because it doesn't have to move forward. So fixed wing aircraft has to move forward because unless it move forward, you cannot get a relative motion with respect to the air and then generate a lift. In flap rotary wing, which helicopter we just discussed today, when you have a rotating wing, you can, since there is a motion, relative motion, you can generate a lift. The same way, the birds flap their wings and they can flap in specific patterns and then generate a lift. Most birds require the flight in the forward direction to to provide sustainable lift. But hummingbirds and some insects can produce these primarily linked to the flapping patterns, but there is little more to it. If you look at the way, if you plot, let's say, the weight and the length or difference of muscle power, all those things for different birds, hummingbirds, there is a scale, there is a region where if you think of a graph and then you plot these parameters, you will see that insects will be on one side, birds will be on slightly different side. This hummingbird is somewhere in between. So its scaling properties, like what is its weight to the length, I mean, the body mass, I mean, the weight of the body mass to the length or the flapping frequency, they all are slightly different, both from the insect as well as from the birds. They are somewhere in between. But overall, that is, I mean, right now with what we have, I mean, with to communicate with the students, school students, this is all I can tell. The flapping patterns and specifically the how the flapping frequencies or the body weight is fixed by nature, that permits them to do this kind of work. But more, we should understand from the flapping patterns kind of thing. And they are very complex. It's not that it's unlike the fixed wing aircraft or helicopter slightly different, but fixed wing aircraft, it is mostly unsteady flow stages. So it's not a steady scenario. Helicopters also, it's a little unsteady, but flapping things are much more complex. There a lot of unsteady aerodynamics also involved in it. It's not like a steady, you are moving at a constant speed. It's unlike that. So it's continuously changing. So there is something called vortices that are shared. There are the lift patterns also continuously changes. But even though the lift may be changing with respect to time, there is an average lift that will be compensating for the weight, and that's why you will see that it is stationary. But if you really look at it sharply, it may not be fully constant. I mean, minutely, if you look at it, there may be small displacement happen. It happens to the helicopters. It's like a small vibration kind of thing. So that will be there.
Yes.
But more or less, the flapping pattern is what distinguishes them and gives them capability.
Yes, sir.
Any other question?
Good evening, sir.
No, sir.
Yeah, good evening.
I'm Sita, and right now I'm studying my class 11.
Yeah.
And I feel more connected to the subject because almost all the concepts are very familiar.
Okay.
And
Good.
I'm very grateful for having this session. Thank you very much, sir, for explaining our doubts. I'm very grateful for that.
Very happy to know you.
And really, I'm enjoying this aerospace classes. I'm felt really interested. I'm already interested in physics subject. Apart from that, you made aerospace more interesting. Thank you very much.
Good. I hope you'll be able to study also aerospace in future.
Yes, sir. Thank you. That's it, sir.
Good. Thanks.
Thank you, sir.
Anybody else have any questions? If not, we will stop and probably meet next week. Okay.
Sir, next week do we have session?
Yeah, next week we will. I think the week 8, no. So we will have probably just small discussion on how quadrotors fly and probably
Okay, sir.
beyond what are the components. I think that is the content in the week 8. So we'll just have a quick review of it, and if you have any questions on the content, we can answer that also.
Okay, sir. Thank you, sir.
Anything from your side?
Sir, nothing else.
We'll end this.
Do you have any more doubts? I can, if you want, I can say it.
Okay, then we will meet next week. Thank you. Bye.
Fine. Thank you. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Apply